7.4, midpoints and medians and triangles. So we're just going to look at a couple definitions. So what is a midpoint? Well, a midpoint is the point that divides a line into two equal segments. So for example, if the line is from A to B, the midpoint is the point right in the middle. Okay, and we associate this with a theorem. So a line segment joining the midpoints of two sides in a triangle is parallel to the third side and is half as long. Okay, so parallel and half as long. So if we have a triangle like this and we have A, B, C, D, E, this is D. Okay, if we find the midpoint of AB, let's call it D, and the midpoint of AC, let's call it E, this line right here is going to be parallel, and you can see by these arrows here, it's going to be parallel to BC, and then also it's going to be half the length. So half the length, and then that's going to be some length. Okay, second definition, median. So the definition of this is the line segment joining a vertex of a triangle and the midpoint of the opposite side. So here's a triangle, we can call this ABC. If we went from the vertex A and we joined it with the midpoint of BC, so just to note, this line and this line shows that this is a midpoint because let's call this M, like midpoint. B to M would be the same length as M to C. Obviously, it cuts it in half. Okay, so what a median actually is in green, it's this actual line here. Okay, and the theorem that we use sometimes is the point at which the medians intersect is called the centroid. So this is a centroid. And the centroid divides each median into the ratio 1 to 2. What this means is from here to here, this would be 2 units, and from the centroid to the midpoint, it's going to be 1. So it's like a 2 to 1 ratio, or a 1 to 2 ratio. Next definition, bisect. So when we talk about bisect, we talk about dividing something in half. Okay, so a theorem that we use is the medians of a triangle bisect its area. So if we have triangle ABC, I'm just going to highlight the median from angle A to the midpoint of BC. If we drew this median, it would bisect the area. Okay, so we have A to, let's go M. A to M and M to C are going to be the exact same length. Again, that's going to be the median, so that's the midpoint. And the area of, I'm going to say green, is going to be the same as the area of the purple here. Okay, and as you can see, half the area, half the area. Okay, so those two triangles are not equivalent in the sense where they have the same lengths and like side lengths and angles, but they are equivalent in area. Okay, and the last one we're going to touch on is perpendicular bisector. So what is this? This is when you draw a line from the midpoint. Okay, so let's call this ABC. Let's call this midpoint M. So midpoint M is the midpoint of BC, so it bisects BC. Okay, and we draw this, and we draw it perpendicular, so we draw it straight up. Okay, and that's why there's boxes in these corners of these three perpendicular bisectors. Okay, this does not have to go through the vertex. These theorems are going to come back even more next year. They're just touched on just very briefly in grade 9, but in grade 10 they're going to come back. So the theorem that we use is the point at which the perpendicular bisects intersects right here, I'll do it in blue, is called the circumcenter. Okay, that's what it's called. So example 1, calculate the length of the line segment XY in each of these triangles. Okay, so XY, we can see that X and Y are both occur at midpoints. Okay, so if this was ABC, and you're allowed to do that if you have a triangle and it's not labeled, you can go ahead and label it. Okay, X is the midpoint of AB, Y is the midpoint of AC. We can see that because these dashes here show that these two parts are equivalent, meaning that it cut it right through the middle. Okay, so the theorem that we have is that these two lines here, XY and BC, so XY is going to be 1/2 of BC. Okay, so XY is going to be 1/2 of 10, which gives us 5. So the measurement of XY is 5 centimeters. Okay, and we're only calculating the length. Now the next one, XY, XY, and the reason why we have XY identified is because we want the length of XY. So if this line here is 4, and we can clearly see that this again is these 2 points, let's just call it AB, that's fine, and then we'll call that XYZ. So A is the midpoint of XZ, B is the midpoint of YZ. So AB is going to be half, AB is going to be half of XY. Okay, well we know the measurement of AB, it's 4. Okay, but what we want to do is we want to solve for the measurement of XY. We can just divide both sides by 1/2. So how many halves is in 4? Well, it's 8 halves. And we'll put centimeters on that. Those are our 2 final answers. Example 2, triangle ABC, so that's the big one here, is 16 meters squared. So that's clearly telling us the area. Okay, as soon as we see the squared, we know that they're giving us area. Calculate the area of triangle ABD. So just to wrap our heads around this, ABD is this triangle here. So we know triangle, so the area of triangle ABD is going to be half the area of triangle ABC. Okay, so the area of triangle ABD is going to be half of like that 16 meters squared, which is actually 8 meters squared. Okay, so in all, this one would be 8 meters squared, this one would be 8 meters squared, and the full thing, ABD, ABC, yeah, the full thing would be 16 meters squared. Okay, example 3. Triangle WXY, so we have WXY, which is this little one here. This one here is 13 meters squared, the area. Calculate the area of WXZ. So if we look at WXZ, okay, so the area of triangle WXY is going to be half the area of triangle WXZ. Okay, so the area of WXY is 13, and that's going to be half the area of triangle XZ. So we can divide both sides by 1/2. And how many halves are in 13? Well, there's 26. So the area of triangle WXZ, which is the big one, is going to be 26 meters squared. Okay, so going over here, this is 13, this is 13, so the full one is going to be 26. Okay, example 4, given that CH, so let's label this, so C, I don't like that, let's go green. Here we go, CH, which is here, equals 10x minus 8, and then FC, which is here, equals 3x plus 2, find the value of x. So when we look at this, we can tell that G bisects BH, because there's double dash, showing that they're equivalent. E bisects AH, because there's triple dash. Okay, and then F bisects AB, and then those single dashes there. So we know that these two measurements are going to be in a ratio of 1 to 2. Okay, so this is a little bit backwards. So 10x minus 8 is going to be the bigger one. So this is going to be, because this is doubled already, this is going to be 2 times 3x plus 2. And that's the equation that we get when we do that. It's a 2-to-1 ratio. Okay, and we can expand this. So we have 6x plus 4. Move that over, move that over. We get 10x minus 6x equals 4 plus 8. 8, 9, 10, 11, 12. We get 6x equals 12. I get x equals 6. Okay, and then we can just do it as 6. Find the length of FH. So what's FH? FH is the entire length. So FH is going to be 3x plus 2, okay, the length of the first segment, and then 10x minus 8, okay, we're going to add the length of the second segment. Because we found that x equals 6, we're going to sub that 6 into where we see the x. Okay, I get 18 plus 2 plus 60 minus 8, 60, 72. Okay, so we get 72 units. And if there are no units associated, so it doesn't say that it's centimeters or meters, we can just put units because it is a length, so we have to have a unit in there.